Okay, welcome to another INB382 demonstration video. This one is on the texture animation Unity demo that I provide with the lecture notes. So we can see it's a very simple demo. It's just a quad sitting in 3D space with a camera in front of it. It's nothing special. But of course this object is textured, as are most objects in a game. And what we're going to need to cover here is just aspects of how we get this texture to appear on the surface of the object. So what I'm going to do is just run it. And as we can see there, I'm animating the texture by modifying its coordinates. We're showing this in the script. But some aspects of the texture, filtering and so forth, are also exposed in the inspector. So we have a number of ways of modifying this. But of course I've overwritten it by applying them through the scripting, which I'll show in a minute. So anyway, there's our texture as it's moving in space. And as you can see here, the resource is just a texture. We can create lots of other resources here and add them. So we can import a new asset and haul in a new texture. I'll leave you to sort of sort yourselves out with that. But as you can see here, this is just a JPEG file which has been loaded up, Vegas, inside the default resources directory, which is handy within Unity because the resource loading functions in C# look in that directory first. So without further ado, let's wander across. Let's have a look inside the texture first of all. And we see some of the things I mentioned in the lecture are available to you in the inspector. First of all, here's the texture wrap capability. This refers to the, the end or boundary condition occurrences with texture coordinates. What happens when you get to the end of a texture coordinate? So either you stop at the final value, so you just get the border appearing and repeated, which is clamped, or you repeat. It just starts from the start of the texture again and repeats it. That's a very common one, repeat, because that's often used when you want to just simply replicate the texture across a surface, such as a rock face or wood or some sort of paint texture, whatever. So repeat is often a common one to use. The filter mode covers all the sampling modes that are possible. So point, of course, being the simplest, as I show in the lecture notes. That just samples the nearest point. Bilinear is obviously a bilinear interpolation across the surface of the surrounding points. And trilinear represents the the interpolation through the layers of the map pyramid inside the graphics card, which I cover in the lecture. So as you can see, these features are available to you in the inspector if you wish, but you can control them in the script, which is what I prefer you guys to do, because that's more programming and less just twiddling a GUI. The other aspect here, the parameters exposed, is the quality of the anisotropic sampling. So of course this is the distortion capabilities of along the leading dimension inside the distorted pixel, which I talk about in the lecture. So obviously the value here goes from 0 up to 16. And so this controls the length of the leading dimension that will be sampled, and will also therefore control the quality of very distorted pixels at the horizon, which we'll see with the anti-aliasing demo. Just a note here as well, if we play around with this factor here, we can go through the mip-map. So the mip-map obviously is a subsampling through a pyramid of the texture coordinates, which I cover in the lecture. And so we can see here that that's mip-map level 8, which is the top, the single pixel, which is just a straight color. But it's stretched, of course, to fit the size of the texture for the interface. And as we go down the levels, we come to the bottom level, which is the original image, which hasn't been subsampled. So that just gives you a visualization of the levels within the pyramid. You can refer to the lecture to see all of that as well. So you've got access to that too. Moving right up, we move across to, okay, so the texture, of course, it's the... keep on changing things, so ask me to apply them. So we have our material here for the texture animation, and of course that has a shader attached, which is the texture animation shader, so it's just the same as all the other material shaders. So you can assume this. I've created a material and dropped onto that material, the shader. I'll go to the script first just to show you the scripts for loading that texture. So the texture is in the resources directory and we want to load it onto the object. So here we go. Here's our bog standard simplistic sort of scripts that I have for these demos. And in the start function, or start method, sorry, we have here that we create a texture. It's of type texture 2D. That's the class that's offered to you in the script. And we use the function resources load Vegas, the name of the file. We don't need the suffix because that will be looked after by the Unity C# script to load it up. And we want to load it as type of texture 2D. And then that texture, of course, has various parameters which we modified. So we've got a filter mode. That's corresponds to the interface and the theory that I show you in the lecture. We have a wrap mode, which again here, so we've got here, it's trilinear filter through the bitmap levels, and it's turned on to repeat, and we've put the ISO levels up to 9 here. I think the scripting only restricts it to 1 and 9. I'll better check that in a minute, but you can play around with that number. One of the other key things here is then that we need to pass this texture to the shader so that it's able to use it. So we do that via, if we go to the shader for a minute, the properties header. So going back to the script, just as always, renderer.material and set texture and the name of the variable inside the shader, so underscore main texture. So that's all fairly straightforward. And that gets that texture into your shader so that it's able to effectively, what happens, it's all loaded up onto the graphics card, and then the pointers are lined up in memory on the GPU, and then when it goes to sample an image, it's going to go to the correct image that you've loaded in the resource memory on the GPU, which is underscore main texture. So going to the shader, okay, again, because it's a uniform parameter, that's not a varying parameter, so textures are not varying. The texture coordinates are varying, and I'll get to that in a minute. This is a uniform parameter, so therefore we have to declare at the top of properties so we can make it exposed inside the inspector. And we have there, it's underscore main texture, base RGB 2D, and its default value is white. So if it's not loaded, you get a white quad. Moving right through, the rest of the shader is really straightforward. We replicate, of course, that property down here. That's the uniform variable we're using. And then we've got some quirks here in Unity regarding the way texture coordinates are transformed. But one of the things we show down here is that in the vertex shader, so this is our vertex shader for the quad, we're going to play around with the texture coordinates. So I've mentioned in the lecture that each vertex comes through with a texture coordinate. That texture coordinate is manipulable. So you can take that and you can apply a transform. We apply a really simple transform, which is just we add time to the X component of the texture, or the S component if you were to use the proper nomenclature mathematically. And here I just use the Unity value time and added some other texture coordinate offset if I need. I've just set it to 0 there because I think I start from scratch. I don't need to move it initially. And I just add the time variable to the X coordinate. So that's automatically updated by Unity. It's a handy variable to use for animations. And as you can see here, it just adds the value to the X coordinate. And thus we get the effect when we run it of the texture moving from right to left. So this means that you can animate your text. Simple example, but it enables you then to, if you want to, implement rivers by moving a water texture through a section. Or if you want more complexity, you can play with these coordinates, introducing noise, all sorts of things can be done to those coordinates and played with. This is just a very simple demo to show it's a coordinate that can be changed. And then finally, if we want to sample it, the whole idea is that once, so the texture coordinates are moved and animated, once we get to the pixel shader, the whole idea is that all this pixel shader does is says, right, at the texture coordinate for the pixel That's been all interpolated. Remember the normals, and in the rasterization system, the pixels are generated, the X and Y coordinate on the screen in the frame buffer. At the same time, the normals are interpolated. We don't use them here. I've shown you a lecture last week that happens. And the texture coordinates are interpolated. So those output values from the vertex shader, when they come into the pixel shader, they are correctly interpolated for that pixel. So you've got, if your initial values are correct, you've got the correct texture coordinate to sample the image and to hold out at that pixel location the color from the texel space. And that's very simple in a pixel shader. It's just tech2d underscore main text and just the coordinates. So you're saying from the image, give me the pixel at this location. Understanding, of course, that this sampling is modulated by all these parameters we've set up here. Okay, so that's automatically implemented when you make this call here. And that means that the pixel value should come out correctly. And for our demo, moving back here, we get the Vegas sign showing up on a quad. So that concludes the texture animation demo. Thank you very much.